Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. It says a right-angled isosceles prism of refractive index n1 is placed in a medium whose refractive index is n2. So this is the right-angled isosceles prism and the refractive index of this prism is n1. It is placed in a medium that has a refractive index n2. The path of ray of light that falls normally on side BC of the prism is shown in the image below. So this is the ray of light that is normal to BC surface, and we all know that when the ray is normally falling on some surface, it will move without any deviation because I is equal to 0 for this ray, and angle of refraction will also be 0 because if we apply the Snell's law at this point, R will come out to be 0. So the ray will move undeviated. So it will move in a straight path, and then when it comes out from the AB surface, it gets deviated. And we can see that it is deviated away from the normal. So let's draw a normal here. This is the normal to AB surface, and the ray is deviating away from it. The value of N2 is under root 2. We need to find the possible value of N1. So let's try to apply the Snell's law at AB interface. So applying Snell's law at AB interface. So we can say that the angle between the incident ray and normal, so this angle is my I, and the angle between the refracted ray and normal is R. So we can say that if this angle is 90, this is 45, this will be 45. So I will also be 45. So I here is 45 degree, and we don't know anything about R. Let's apply Snell's law here. So we know Snell's law is sine I upon sine R. It is equal to N2 upon N1, where N2 is the refractive index of the medium to which the ray is going, and N1 is the refractive index of the medium from which the ray is going. So we can reshuffle it as N1 sine I is equal to N2 sine R. We need to find the value of N1. Sine I is sine 45. So it will be N1, it is equal to N2 sine R divided by sine 45. Sine 45 is 1 by root 2. So we can use that value. So further, I am solving it here. N1 is equal to N2 sine R divided by 1 by root 2. Sine 45 is 1 by root 2. Root 2 will go in the numerator. So N1 will be equal to N2 times under root 2 sine R. Now we need to find the possible value of N1. So what can be the possible value of this R that will decide the value of N1? N2 is given to us as under root 2. We can put that value here. So N1 will be equal to under root 2 multiplied by under root 2 sine R. That will be 2 times sine R. Now, what can be the least value of R? So R is greater than 45 because I is 45. So R is greater than 45. So R is greater than 45 and R is less than 90. So that's what we can conclude from here. Because if R would have been 90, then ray would have been grazing on the surface AB. So let's assume the value of R, what can be the minimum possible value? It is something greater than 45. And what can be the maximum possible value? That is something less than 90. So we know the value of N1, it is 2 multiplied by sine of something greater than 45. So R is lying between 45 to 90. So we can check at the boundaries. So if it is at 45, so N1 will be equal to 2 into sine 45. So that will be 1 by root 2. That is root 2. And if it would have been 90, then n1 will be equal to 2 multiplied by sine 90, then it will be equal to 2 only. So we know that n1 is having some value that is greater than under root 2 but less than 2. Under root 2 is 1.414. So this value is out of question because it is lesser than 1.4. And then second value is 1.6. This can be possible because it is greater than 1.4. And we have also concluded that n1 is less than 2. So this value is not possible and this value is also not possible because it is greater than 2. N1 can never be equal to 2 as well because it would be 2 when R is 90. So the only possible value that is remaining is B, that is 1.6. So N1 can have value that is greater than 1.4 and less than 2. The options that are given to us, B is the correct answer. Keep learning, keep practicing, keep excelling.